Good afternoon. Our lecture for this afternoon would be demography. So for demographics, it's most often related to the population. For example, this table shows the most populous countries in the world, June 30, 2016, in the million, showing China and India as the most populous countries. So this is the study of populations and integration of all these population data with social and economic conditions with special reference to fertility, mortality, growth, migration and vital statistics, age distribution, etc. So your demography could be structural, so it's considered with a point in time, and dynamism considered with period of time. So examples of structure in the demography would be age, sex, education level, income, households, family, urbanization, utilities, and information on home and facilities. Dynamic would be vital statistics, for example, birth rate, fertility rate, reproduction rate, marital status, and migration, emigration, immigration status in your country. So there are different sources of demographic data. Population structure could be census, calculation, microcensus. Population dynamics sources could be your registration of birth and deaths, registry, immigration registry, and causes of death. So, for example, this is coding for heart failure according to the ICD-10. So, demographic structure presented as the gender structure would be sex distribution and sex ratio, age structure, as mentioned. So, there are a lot of age structure by population, by female population, age dependency ratio, etc. So we often see in demographics the age sex pyramid. So this is the demonstration of the demographic structure of the society. So your x-axis would be the life years of women and men. So this is the basic unit of this category and maybe a single year or groups of more years. So vertical axis would be the number of persons of each age group. So to change the axis, the vertical one will show the age categories, and females are traditionally on the right, males on the left side. So there are different types of age sex pyramid with stages 1, 2, 3, and 4 respectively. So stage 1 would have a high birth rate and would have a rapid fall in each upward age group due to the high death rate. So remember, high birth rate and high death rate would be your stage 1. Stage 2 would be a high birth rate and there's a slowly declining death rate as more people live in the middle age. Stage 3 would have a declining birth rate and a low death rate, so more people live to the old age. And a low birth rate and a low death rate, because of longer life expectancy, would lead to a stage 4 or a contracting age sex pyramid. So interpret this. This is the Philippines age sex pyramid for 2013. So there are a lot of young people, expanding population, such that 2000 it's a stage 1 age sex pyramid. Same way in China, 1990. So still resembles a stage 1 age sex pyramid, but you could surmise what happened around 5 to 10 years ago for to affect children 5 to 10 years old. So this is China 2013 with a large middle-aged population, slow old population, and low young population. This may be a result, for example, of a one China policy wherein they're just permitted to have one kid. Japan's low birth rate resulted in this pyramid, low birth rate, and an expanding middle age, which closely resembles a stage 2 or a stage 3 pyramid. So this is another summary of your stage 1, 2, 3, and 4, as well as 5 declining pyramid, and showing birth rate and death rate respectively, with examples of your country. So population dynamics. These are diversities in demographic situations across countries and regions, as well as within countries. So there are two driving forces behind these evolving demographic changes. So there's biosocial phenomena, these are your birth rates and your death rates, and social phenomena such as your internal and international migration. So these again are affected by different things. So remember your structure and your dynamic aspects or determinants of demography as they are classified. So natality. So by definition, birth as a natality event means live birth contrasted to the stillbirth that occurs when a fetus exits the maternal body and subsequently shows any signs of life as heartbeat, pulsation, and voluntary movement. So complete birth is the infant's entire separation from the maternal body after 42 completed weeks or 294 days of gestation. So birth may be singleton, multiple, preterm. So that is birth before 37 weeks, or low birth weight, which means birth weight less than 2,500 grams. Okay. So crude birth rate as computed is the number of live births in a year per 1,000 population. So birth would be the number of live births over mid-year population times 1,000. So the first total number of live birth is divided by the mid-year population of the referred territorial unit, and the outcome has to be multiplied by 1,000. So for example, the crude birth rate of Hungary, so number of live births would be 85,000. Mid-year population would be 10 million. So using the formula, 85,000 over 10 million is equal to 0.0085 times 1,000 would be 8.5. So a basic rule would be rates are related at least to one whole person. Thus, the outcome has to be multiplied by 1,000 to get 8.5. In other words, 1,000 persons are producing 8.5 live births. So preterm, you just look at the number of preterm born infants per 100 live births in a year. So preterm births would be number of preterm births over number of live births times 100. So example, country's PTB rate would be 7,225 over 85,000. This is number of preterm births in Hungary over the number of live births, which was 85,000, which equals to 8.5%. Calculating the low birth rate, so you get the number of infants with low birth rate, then multiply it by 100. So for example, using the previous example, 7,140 live births, low birth weight infants over 85,000 live births would result in an 8.4% of low birth weight rate percentage. So for fertility, this means a childbearing capacity of the population represented by women between the ages of 15 and 49 years. So fertility rate is a number of births per 1,000 women of specific compositions. So your general fertility rate, there is your age-specific fertility rate and your total fertility rate. General fertility rate is the number of live births per 1,000 women between ages 15 to 49. Age-specific, the number of births to women of a particular year, age, females in the groups, for example, 20 to 24 years. So, as an example, total fertility rate is the average number of children a woman would bear during her reproductive lifetime, assuming her childbearing conforms to her age-specific fertility rate every year of her childbearing years. So, for example, for Hungary, so as listed the age of the woman, so number of children, number of women, and fertility rate for each category. So number of children per women in 5 years. So you just add that, and that is your total fertility rate. So from a biological point of view, PFR indicates clearly the trend of the human reproduction. So cut value is 2. Anything greater than 2 means your population is growing, and less than 2 means your population is in the decline. Okay? So for total fertility rate, this is the demographic map for 2010 to 2015, children per women. So you will see countries wherein there would be a high population rate, base total fertility rate. So that's basically in Africa, South Asia, Southeast Asia, and your developing countries would have a decreasing population, such as your Japan, Germany, etc. So, mortality, on the other hand, is a relationship of death cases to the whole population. So, there are two basic types of mortality: general mortality rate or death rate, specific mortality rate, age and sex related, disease related or cause related, and life expectancy. So let's look at them one by one. So crude death rate or mortality rate is the number of death cases in a year per 1,000 of the population. So this is the number of death cases over the mid-year population times 1,000. So for example, death rate is 135,000 over a population of 10,000, death rate would be 13.5. If it's age and sex related mortality rate, crude mortality rate can be computed for both genders and age group. So the age group under 1 year is separately treated. So that is your infant mortality. So general population 40 to 49 years. So number of death cases of the cohort and mid-year population of the cohort times 1,000. So you get 4,677. That's the death for 40 to 49 years over your mid-year population, which gives you 3.6. So if you get your female population between 40 to 49 and your male population between 40 to 49, and you will see that you could also compute for your age and sex related mortality rate using the same formula we used in the prior slide. Infant mortality rate would be separate. So the number of death of infants that is under 1 year in a given year per 1,000 live births occurred in the same year. This rate is divided up for 4 subgroups and often used as an indicator of the level of health in a country. So number of deceased infants over number of infants under 1 year of age times 100 would be your infant mortality rate. So these would be indicators of the level of health of the community: perinatal mortality within 24 hours, postnatal within the first week of life, neonatal mortality, death occurring at 7 to 27 days of life, and postneonatal mortality, death occurring between 28 and 365 days of life. This is all included in your infant mortality rate, and we can separately compute the following as well. So we could compute for your general infant mortality rate as we have computed in the previous slide, your perinatal mortality rate. So this is a separated perinatal mortality, first 24 hours, and will not include your stillbirths. So Hungary's perinatal, so number of infants died within the first 24 hours, number of infant borns given in a year. Same way with postnatal mortality rate, you compute it with infants who died 0 to 6 years using the same denominator. Neonatal mortality rate, days 7 to 27 using the same denominator. And postneonatal mortality rate, 28 to 365 using the same denominator, which um, of course, you have to know which numerator to use and the definition of post-neonatal mortality, neonatal mortality, and post-neonatal mortality values. So this would be fetal losses and infant deaths, intrauterine and extrauterine. We term it fetal if it's intrauterine, infant if we have already delivered the baby. So, from 0 to 42 weeks, less than 20 weeks or less than 1,500 grams, that would be an abortus. 24 weeks and up to 42 weeks without life, that is stillbirth, and that would be considered perinatal mortality. 0 to 6 is postnatal, to up to 27 days would be natal, and post-neonatal would be up to 1 year. So fetal loss, as we have seen in the previous slide, is defined as the total sum of fetal death cases and induced abortions. So fetal death cases may be related to the number of live birth or the number of fertile female population. Fetal death rate would be equal to the n number of fetal death cases over number of infants born in a given year times 100. So, for example, 17,220 over 88,049 would be times 100. Fetal loss would be at 19.6%. So abortion is the termination of pregnancy, either spontaneous or induced. In demography, abortion means induced and legally related procedure for termination of pregnancy, irrespective of medical or other legal reasons. Another indicator would be your maternal mortality. So this is a special case of sex-related mortality, and this would represent death cases of women who died during pregnancy and childbirth, inclusive of the first 42 days after the delivery. So number per year is relatively small in developed countries, thus maternal mortality rate is computed per 100,000 live births. So maternal mortality is computed as n of maternal deaths over n of infants born in a given year times 100,000. Cause-related mortality, so it's concerning only the main types of diseases, for example, motor vehicle accidents and suicide, stroke, hypertension. Life expectancy is the average number of years an individual of a given age is expected to live if current age-specific mortality rates continue to apply. So every cohort had different experiences in its earlier life that might have influenced its mortality rate in a given year. So life expectancy and birth would be the average number of years a newborn is expected to live if current mortality structure persists throughout its life. Because of the gender difference, life expectancy is calculated also separately for men and women. Life expectancy is a hypothetical measure and indicator of current health and mortality conditions. So, population growth could be computed as crude birth rate minus crude death rate. So, this is the end of the lecture. Be ready to answer this crossword puzzle. This would serve as your quiz for this afternoon. Link for the live lecture would be provided. Thank you.